want to show you two ways to do this example, working with each side separately and then possibly just working on one side only. So we have verifying the identity cosine squared of theta over 1 plus cosecant of theta. So let's start with the left side. So we have cotangent squared of theta. Let's remember what that reminds us of. 1 plus cotangent squared of theta equals cosecant squared of theta. Now we have to subtract 1, so it looks like it. So cotangent squared of theta equals cosecant squared of theta minus 1. So I'm going to subtract, put that in the numerator there. So this is cosecant squared of theta minus 1 over 1 plus cosecant of theta. Cosecant squared of theta minus 1, we can actually factor that to difference of squares. So cosecant of theta minus 1 times cosecant of theta plus 1 all over 1 plus cosecant of theta. I hope you see that this is the same. I know it's written, differently, but it's still the same exact thing. So notice the answer is cosecant of theta minus 1. Now at this point, I'm going to go ahead and start on the right side and see what I can do with this one. So we have 1 minus sine of theta over sine of theta. So what we can do is go ahead and split this up. So 1 over sine of theta minus sine of theta over sine of theta. And I can simplify that. 1 minus sine of theta, that is cosecant of theta. And then sine of theta over sine of theta is 1. So if you do this, you work on each side and you get to this halfway point, the next thing that you must do is you must tell me this. Because, you have to write it, because cotangent squared of theta over 1 plus cosecant of theta equals cosecant of theta minus 1, and 1 minus sine of theta over sine of theta equals cosecant of theta minus 1, then cotangent squared of theta over 1 plus cosecant of theta equals 1 minus sine of theta over sine of theta. Okay, so if that's what you decide to do, to work with each side separately, then you must, after verifying up to the halfway point, you must justify it with words as to why that works out. Now, the other option is just to continue with this left side and not do anything with the right side. And I would argue that you could do that. Seeing this cosecant theta minus 1, that you could continue that and get to this one over here. And so sometimes when you start to mess with both sides, you can kind of see, oh, I could make it the one on the right or the one on the left by manipulating it a little bit more. So let's go ahead and do that. I'm going to go ahead and erase this here. So let's just do this problem and just continue it from the cosecant of theta to try and see if we can get it to match the 1 minus sine of theta instead. Okay, so let's do it that way. So cosecant of theta minus 1, let's rewrite that. Cosecant of theta minus 1, we can write that as 1 over sine of theta minus 1. Then because this is 1, remember we could change that. 1 we can just write as sine of theta over sine of theta, because sine of theta over sine of theta is just 1. So now we can combine these. So since we have a common denominator, we can rewrite it, and we have 1 minus sine of theta all over the common denominator of sine of theta. And notice that we verified it with the right, and we were done. We don't have to write anything. We verify like we did before. Now you do, like I said, you do have a choice of working with both sides and getting to the halfway point, but you must just find words just like I did previously. Try this next example below. So this one is very similar to the other problem, and so hopefully you were able to do this. We just worked on one side. So I worked on the left side, and so this is my flow of work here. So I changed tangent squared of theta to secant squared of theta minus 1, factored it, canceled out the secant theta plus 1. Then I have secant of theta minus 1, converted to 1 over cosine of theta minus 1. And then I know the 1 I can write as cosine over cosine with the same denominator. Then I can combine it. 1 minus cosine of theta over cosine of theta, and now I have verified it. Now let's do these last examples. So 2 examples from calculus. We want to verify each identity. We have tan to the 4th x equals tangent squared of x, secant squared of x, minus tangent squared of x. Let's work on the right side. what we can do is factor out a tangent squared of x. Then we're left with secant squared of x minus 1. So let's look at that. Tangent squared of x plus 1 equals secant squared of x. Subtract 1. So this is tangent squared of x equals secant squared of x minus 1. So I'm going to substitute that for in there. So notice that we get tangent squared of x times tangent squared of x. Therefore, this is tangent to the fourth of x. And so we have verified it. Letter B. We have cosecant to the fourth of x times cotangent of x. So one thing that we can do is, I notice I have cosecant squared of x. Let's work on the left side. It's up to you whichever side you want to work on. But I'm going to do this side. So cosecant, I'm going to split it up to square root of x. And then I'm going to write it as cosecant square root of x times cotangent of x. Cosecant square root of x, that reminds you of 1 plus cotangent square root of x equals cosecant square root of x. So I'm going to replace 1 plus cotangent square root of x for cosecant square root of x. So I have cosecant square root of x times the 1 plus cotangent square root of x times cotangent of x. And so next, so we're almost here to what we were trying to get to, so we start on the left side, and then we're going to distribute. So now we have cosecant square root of x times cotangent of x plus cotangent cubed of x. Okay, and then we have verified this right side. And again, you could start from the right and do the left. That's okay too. So try these two examples here. Okay, if you tried this out, on the left, that's very similar to the one above. So I worked on the right side first, I factored out a tangent of x, and I have a secant squared of x minus 1. That changes to a tangent squared of x, and so you see that it becomes a tangent cubed of x. For letter B, I worked on the left side, and so what I did is I just changed this to, instead of sine cubed of x, I made it a sine of x and a sine squared of x. Then I changed the sine squared of x to 1 minus cosine squared of x. Then I distributed this side, and so I got sine of x times cosine to the fourth of x minus cosine to the sixth of x. And then trying to make it match this entire right side, I just flipped it. And so I have cosine to the fourth of x minus cosine sixth of x, all multiplied to sine of x.